Hey all, today we are going to be talking about quadratic functions some more, and we have so far graphed them, and we have found some special points, the vertex, a y-intercept, and potentially 2, 1, or 0 x-intercepts. So I'm going to use the same problems we used in the last lesson, and now we're going to be identifying the domain and the range. And the domain uh, of a quadratic function, or of any function, the domain is all the possible x's. So remember when we have any sort of graph, so a line, or in this case a parabola, those things are made up of an infinite number of points. And points are locations, and locations always have an x, and those locations also always have a y. And so when we're putting those points onto, in this case, the parabolas, um, if we collected all the possibilities for the x values of those points on a parabola, that would be called the domain. If we find a collection of all the possible y's, I'll just say all y's. If we find the collection of all the possible y's, that's the range. So domain is all the possible x's when we find the coordinates of points. Range is all the possible y's when we find the coordinates uh, of all the points. And so let's look at our first function. And so we talked about clicking on this thing, we could find the vertex, we could go up and we could find the y-intercept. And then in this case, this one did not have any x-intercepts because it doesn't cross the x-axis. So now we want to talk about, well, that's one point. That vertex is one point. What if we went to find all the points? So we could slide a point up here, and you can see as I go that the x and the y values are going to change. As I go this way, they're going to change. And you can see most of the time they're decimals. Okay, so we usually deal with these nice perfect points like this one, -3, 2. But there are points all over this parabola, as I'm showing you, that are decimals. But they always have an x, they always have a number in the front, and then they always have a y. And so if we were to collect all the values for the x's, that would be called the domain. And so what we need to know about this function is that it's going to go up forever in both directions, to the left and to the right. Left and right are my x values. And so if this thing's going to keep going forever and ever to the left, you can see it keeps getting wider, keeps getting wider, keeps going to the right more, keeps going to the left more. It's just going to keep doing that forever. And so that means there's going to be a point on this parabola with any x value we can think of. And so what we would say about the domain, I'll stay with blue for domain. What we would say about the domain is that the domain is all real numbers. Any number you can think of that's a real number, and we haven't talked about imaginary numbers, but a real number, if it's a decimal, if you can write it as a fraction, a square root of a positive number, all these things make real numbers. And so if I pick any x value, this parabola will have a domain, or this parabola will have a point with that x value in it, and so the domain is all real numbers. And so actually, the domain of these functions is always going to be that. So if I look at my next one, let me look at number 3. I know that's out of order. This function's always going to, as I keep going and going and going, it's going to keep getting wider, and that means going to keep going to the left and keep going to the right. And so that means that there's every possible x value I can think of, I can find a point on this parabola. And so whenever we look at the domain of a quadratic function, the domain is going to be all real numbers. So for all of these, it's all real numbers. All real numbers all the time for the domain. So the range is the one that we're really going to have to maybe put some thought into. But that really important point that we've talked about in the last lesson, the vertex, is going to come into play. So let me go back to my first one again, and I can click it, and I can find the vertex. That vertex also has another name depending on how the parabola looks. So this is the lowest my parabola is going to go. It's not going to go any further down. It'll go up forever, but it won't go any further down. And so we can call this vertex a minimum. So this vertex is a minimum because that's as far as it will go down. And when we're talking about the range, the thing we want to look at is the number for y. And so if this is a minimum, that means all the y values are going to be bigger than 2. So if I try to put any point on here, you can see if I look at that second number, it's bigger than 2. Bigger than 2. The smallest it ever gets is 2, and then it increases again as I go back this way. 2 is the lowest it can be, and so here's how we would write it. We would say that all our y values, and this is my range, all our y values are going to be greater than or equal to 2. Greater than or equal to 2. Since this is a minimum, all the y's are going to be bigger than this. Minimum means that's as small as it gets. So let's look at the range for this third one, number 3. Here, if I look at my vertex, that's as high as this thing's going to get. My vertex is -2, -3. We're going to call that thing a maximum. That's as far as this graph is going to go vertically. It's going to keep going down forever, but it's only ever going to get to -3 as far as its height goes. So all my y values are going to be smaller than -3, except for in this one place where the vertex is. So if we wanted to write this range now, we're going to say our y values are less than or equal to -3. And again, we're looking at the y value from our vertex. So one of the very important things here is to make sure we're not getting confused. Our symbols. When we read our symbols, we read from left to right. And so if we see the open part first, that's greater than. If we're reading from left to right and we see the pointy part first, that's less than. And then the little bar underneath means or equal to, because we do have a point here where y is equal to -3. It's at the vertex. So let's look at this one as well. Number 2, even though it's the third one we're looking at. Again, we're going to have a maximum. Our vertex is a maximum. Our vertex is 1, 1. It's a maximum. I believe this is a really good thing to write down every time. And we're looking at our y value, which is 1. So we are going to say y is less than or equal to 1. Since it's a maximum, all our y's are going to be less than where our vertex y is. So I want you to give this one a try. You're going to tell me the domain and the range. So hopefully you notice the domain is always going to be the same. It's always going to be all real numbers, because our parabola is going to keep going on and on and on to the left and to the right. So I can keep going and going and going, and it's always going to keep getting wider to the left and right. Here I have a maximum that's as high as my parabola gets. I'm looking at the y value of 2. That's my maximum, and so that means all of our y values are going to be less than or equal to 2. So if you didn't get one or both of those right, please do make sure you ask for help. As always, we have some practice. Make sure you answer the practice problems. If you get stuck at any point, ask for help so that you don't make the same mistake more than once.